SciCuriousID presents a deep dive into one of nature's most awe-inspiring and destructive phenomena, exploring the hidden physics behind their incredible power. Tornadoes are not just powerful, they can spin at speeds exceeding that of a Formula One car, and in some cases, even faster than the rotational speeds found within certain jet engines. This incredible velocity is a testament to their raw energy. These mesmerizing, yet terrifying, swirling columns of air represent nature's most violent storms. But what fundamental principles allow them to achieve such insanely rapid rotation, defying our everyday understanding of motion?
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
The profound answer to this question lies at the intersection of one of physics' most elegant and fundamental rules, combined with a touch of inherent atmospheric chaos. It's a delicate balance of order and disorder. Tornadoes are born within the colossal structures known as supercell thunderstorms. These towering atmospheric giants can stretch over 15 kilometers high, dominating the sky and creating the perfect breeding ground for extreme weather. Within these immense supercells, a dynamic exchange occurs. Warm, moist air rapidly ascends, driven by buoyancy, while simultaneously, cooler, drier air descends, creating a powerful convection current. This significant difference in both temperature and wind speed at various altitudes generates horizontal tubes of rotating air. This atmospheric phenomenon is scientifically known as wind shear, a crucial ingredient in tornado formation. When powerful updrafts within the supercell encounter these horizontal tubes of wind shear, they can tilt them upright. This action transforms them into a vertical column of spin, marking the critical initial stage of a developing tornado. Once this nascent column of rotating air begins to tighten and contract, its speed starts to skyrocket dramatically. This acceleration is a direct consequence of a fundamental physical law, much like a figure skater pulling in their arms during a spin. The underlying principle governing this incredible acceleration is the conservation of angular momentum, a cornerstone of classical physics that explains rotational motion in countless natural phenomena. It is precisely the same immutable law of physics that causes an ice skater to spin significantly faster as they draw their arms and legs closer to their body, reducing their rotational inertia. Angular momentum, defined as the product of an object's rotation speed and its distribution of mass relative to the center of rotation, must remain constant in a closed system unless external forces or torques act upon it. Therefore, when a wide, slowly rotating column of air, characteristic of the initial stages of a storm, narrows into a much tighter, more compact funnel, its rotational speed accelerates dramatically to conserve its angular momentum. This means that the smaller the radius of the rotating column, the faster its spin becomes. This explains why narrower tornadoes often exhibit much higher rotational speeds than their wider counterparts, even if they are smaller in overall scale and shorter-lived. Inside the most intense tornadoes, wind speeds can astonishingly reach over 480 kilometers per hour. Such immense forces are capable of leveling entire buildings, stripping asphalt from roads, and tossing heavy vehicles around as if they were mere toys. Even more astonishingly, within the main tornado funnel, smaller, intensely rotating suction vortices can form. These tiny twisters can locally double or even triple the already extreme rotation speed of the larger tornado. These microwhirls, though small, are incredibly powerful, with winds that can briefly exceed 700 kilometers per hour, surpassing the fastest surface winds ever officially recorded on Earth. As a fascinating fact, the fastest ground wind ever recorded was measured during a devastating 1999 tornado in Oklahoma. Mobile Doppler radar captured an incredible speed of 484 kilometers per hour, a truly staggering figure. To put that into perspective, 484 kilometers per hour is significantly faster than the typical cruising speed of a commercial passenger jet, highlighting the extraordinary power contained within these storms. And while the lifespan of most tornadoes is relatively brief, often lasting only minutes, their power density, the amount of energy concentrated in a small area, is absolutely enormous. The total energy released by a single, powerful EF5 tornado can be equivalent to that of several nuclear bombs, all concentrated within a spinning tower of air barely a kilometer wide, making them incredibly destructive. Yet, despite all this inherent violence and immense power, tornadoes are surprisingly fragile and delicate atmospheric systems, highly sensitive to their surrounding environment. Even a subtle shift in atmospheric humidity, or a slight change in wind speed by just a few degrees can be the critical factor that allows one to form, or conversely, causes it to dissipate and vanish in mere seconds. Inside the core of a tornado, the air pressure can plummet by more than 100 millibars. This drastic pressure drop is so significant that it can cause buildings to literally explode outward due to the pressure differential. As air from the surrounding environment rushes inward to fill this extreme low-pressure void, it accelerates even further, tightening the vortex in a powerful feedback loop that continuously drives faster and faster rotation. It is this intricate dance between fundamental physics and atmospheric chaos, where order emerges from turbulent motion, that truly defines the formation and incredible power of a tornado. So, why do tornadoes spin faster than you might initially think? It's because as they tighten and contract, they efficiently trade their size for immense speed, creating a perfect storm of motion and concentrated energy. The next time you witness the awe-inspiring power of a tornado, remember this: it's not some mystical force or magic, but rather the elegant and powerful principle of momentum in action. Curious for more scientific insights and fascinating explanations? Subscribe and stay curious with SciCuriousID for regular updates and explorations of the natural world.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.